Hello all and welcome back to the Over the Wire series. Today we're looking at Bandit 11, which is an interesting look at the ROT13 encoding device. I don't believe it's an encryption. I'm not entirely sure though. So let's go to Bandit 11, input the password. And the way that this video is going to work is we're going to read our brief, and then I'm going to show you the correct command, and then I'm going to try my best to explain it. I can get myself a little bit turned around in my explanations of this one, and I've tried it like 2 or 3 times, and I think I fully understand it now. So we are ready to record the video. So here, let's read the brief after we've checked we're in the right place. Okay, we are. The password for the next level is stored in the file data.txt, where all lowercase a to z and uppercase a to z letters have been rotated by 13 positions. Okay, so for this, we're going to use the tr command, which stands for translate, and we're going to use the cat command to feed the translate command its input. So let's just find what files. Okay, so we've got the data.txt file. We're going to concatenate that, we're going to concatenate that file, and we're going to pipe the output to translate. Translate takes a couple of inputs, but the way we're going to use it is we're going to give it a source array, and we're going to give it a secondary array to map to, which is its translation array. So let's just quickly read what's in the file. Yep, this is why this encryption, this ROT13 encryption or encoding, isn't very secure, because already you can tell that by the length of these encoded strings that's probably going to be this word is going to be password is followed by the password. Anyway, so we're going to give the output of cat data.txt to translate, which is going to take an array to initially map the string to. Now the array is going to be the regular alphabet, uppercase and lowercase, because we have uppercase and lowercase letters. So let's see how quickly we can do this. A, B, C, D, E, F, G, H, I, J, K, O, P, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and the same lowercase. Let's get this out of the way. Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so that's our first source array. What it's going to do is it's going to take position 1 of G. So this is the character that's sitting in the first position of the password. It's going to go all the way along, and it's going to find either its uppercase or lowercase counterpart in the source array, which in this case sits in position 1, 2, 3, 4, 5, 6, 7. And then what it's going to do is it's going to take position 7 and map that to position 7 in the output array, which is going to be the alphabet but shifted or rotated by 13 positions, hence the name ROT13. Now the alphabet is 26 letters long. If we count in zeros, count with a zero, beginning at 0, sorry, like we always do in Linux, then N is 0, N, O, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then it loops around back to A, B, C, D, E, F, G, H, I, J, K, L, M, and then that's all 26 letters there. And then we're going to do the same in lowercase. Okay, so like we said, this is position 1 of the encoded string. It's going to find that in position 7, and then it's going to pass this, and in position 7, 1, 2, 3, 4, 5, 6, 7 should be T. Yeah, because as we've said, this is probably going to be the word the. And then, if we input everything correctly, we've definitely missed a letter somewhere. Oh, that's brilliant. Alright, you're going to have to bear with me while I do some troubleshooting. I'm really interested now. Let me pause this and I'll get back to you when I've troubleshooted it. Okay, we're back. We found the issue, and it was in the lowercase source string. So now, fingers crossed, the password is here. Okay, for those of you who wanted just the solution to this problem with a brief explanation, there you have it. For those who want to hang around for a slightly longer explanation, and maybe another way to write the command, then please do. So if you're still here, this type of encoding is called, it's called ROT13, but it's a sort of Caesar cipher, or a substitution cipher they call it, and it has a pretty interesting history which I won't get into, but all of those early cryptographic methods are actually really cool. There's one where they wrote messages on slaves' heads after they'd been shaven, and then wait for the hair to grow back and transmit the messages that way. But it's all very cool, the early ways that they tried to hide or at least obscure information from intruding third parties. So this is one of those what we would call like obsolete ciphers or obsolete encryptions, because it's so easily broken. So this wouldn't have many practical applications unless you were like passing a note to a friend in a class, and even then there's slightly more sophisticated ways you could do that. However, enough jibber jabber fool. So we need to take a look at how this is working exactly, because it confused me for a while. And what confused me about this is because the alphabet's 26 letters long, and because the encoded password has been rotated by 13 letters, which is exactly halfway between the alphabet, it means you can write the command with the source array and the output array swapped around with no difference in the output, which is quite confusing. If you think about it, if you just close your eyes and try and imagine that, it's quite hard to imagine. And one of the things that I think is quite interesting about that is that makes the encryption what we call symmetric. So it's a symmetric encryption, as in it works both forwards and backwards. It's the same on both sides in the sense of the word symmetry, and that means asymmetric. It'll give you a clue as to what asymmetric encryption is. So that means that we could swap these around and still get the same output. So I'm gonna quickly do the legwork of typing that out, and I'll join you when I've done that. Okay, so here we have the reversed command, starting with our source array beginning with n, so the rotated by 13 alphabet, and our output array beginning with a, our standard alphabet. And we can see that its output is absolutely nonsensical because we haven't given it the tr command. And again, completely nonsensical. Take two, where our source array is our shifted alphabet and our output array is our standard alphabet. So as you can see, it begins here at n and ends there at m, uppercase and lowercase, and here begins at a and ends at z, uppercase and lowercase. And there we can see that the password actually remains unencrypted. So the reason that is, as I explained earlier, is because it's a symmetric encryption, which means that when it's worked forwards, it still gets the output desired, and when it's worked backward, it still gets the output desired. And that's because it's been rotated 13 times, which is exactly halfway in the alphabet. Now there is one final thing, if I could do it correctly, and you know what? I'll pause before I do, so that I'll save you the pain of, of watching me fumble around. Um, but it's basically a new way that we can type the command to become more efficient using ranges. Welcome back, those of you who are still with us and haven't dozed off. So this is the final iteration of our decoding command here using ranges. Let me just quickly talk you through this. So in substitution for the longhand uppercase alphabet, what we've got is beginning with quotation marks, A to Z uppercase, and in substitution of our longhand lowercase alphabet, we have A to Z separated by a hyphen and end quotation marks. So this is considered the first array within the first quotation marks here, and we have a space denoting the beginning of our second array with this quotation mark here, and then we have N to Z here, which confused me the first time I saw it as well, but our ability to think of the alphabet as a circle that loops back on itself, so when we were doing the alphabet beginning with N the first time round longhand, we quite easily were able to picture in our heads the alphabet looping back round from Z to A. Unfortunately, the Linux terminal doesn't think in these terms, so we need to separate it out for it and say, when you get to Z, I want you to start again at A, and I'd like you to end at M. And that substitutes for our ability to sort of do some mental acrobatics to get back to M. And then the same again in lowercase. So I want you to start, the first character of this array is going to be N, and I'd like you to continue on to Z, and when you get to the end of the alphabet, don't worry, I want you to start again at A and go all the way to M. The next character being N in that scenario. Next character being N in that range to bring us back to the beginning. Alright, and here we can see that it decrypts our password just fine. So if you've stuck around this long, I commend you. Thank you for withstanding my ability to seemingly get that wrong every time, and I really do appreciate it if you have stuck around. Yep, I will see you in the next one.